Okay, so let's go ahead and look at Pascal's principle. Pascal's principle states that if an external pressure is applied to a confined and incompressible fluid, the pressure everywhere in the fluid increases by that amount. Pascal's barrel is an experiment attributed to Pascal, but it is unclear if it was ever performed by him. In this experiment, a 10-meter long tube was inserted into a barrel filled with water. When water was poured into the tube, the increase in pressure caused the barrel to burst. So here is an example of Pascal's principle. The pressure in must equal the pressure out because the pressure here goes undiminished through the fluid to the other side. Pressure is defined as force per unit area. And so we have the force per unit area in is equal to the force per unit area out. And so we can determine how much force is pushing upward here, and we can determine how much force is here. By changing the cross-sectional area, we can change how much pressure we have on one side, which will then change how much force or area we have on the other side. In a hydraulic lift, the large piston has 5 times the area as the small piston. How much extra force can the large piston exert? Go ahead and pause the video. Okay, so let's see if you chose the correct answer. Hopefully you chose D. It'll be 5 times as much as the small piston. The small piston of a hydraulic lift has an area of 10 centimeters squared, and this large piston has an area of 100 centimeters squared. A 40 Newton force is applied to the small piston. What is the weight of the load that can be lifted by the larger piston? Please remember to write out your solution. Go ahead and pause the video now. Okay, so let's take a look at your answer. We know that the pressure in must equal the pressure out, which is the force per unit area in must equal the force per unit area out. Solving for the force out, we end up with force in times the cross-sectional area out divided by the cross-sectional area in. Substituting in our numbers, you end up with a force of 400 newtons. Notice here that we did not convert to meters squared. You don't have to do that when you're dealing with a ratio. In other words, when these units are going to cancel each other out. So notice that we can lift a 400 Newton object with the large piston. The small piston of a hydraulic lift has a radius of 15 centimeters, and this large piston has a radius of 30 centimeters. A 50 Newton force is applied to the small piston. What is the mass of an object that can be lifted by the large piston? Go ahead and pause the video now. Okay, so let's take a look at the solution. We know that the pressure in must equal the pressure out, that the force per unit area in must equal the force per unit area out. Solving for the force out and substituting in, notice here that we use the formula that area is equal to pi r squared. Sorry, I didn't put the equal sign. Okay, area is equal to pi r squared. Substituting in the numbers, notice that pi cancels out, and we end up with 200 newtons. In the next video, we'll cover buoyancy and Archimedes' principle.